Hi, in this lesson we're going to be talking about the sum and difference identities for the sine, cosine, and tangent ratio. These identities are just patterns, folks, into which we can substitute values so that we can find the trigonometric ratios for angles that we wouldn't be able to find otherwise in an exact manner. The sum and difference identities for cosine are shown here, and if you just look briefly at them, in order to find the cosine of some angle that's a difference of two others, for instance, if we wanted to talk about the cosine of, say, 15 degrees, that's not one of our special angles that we know about. However, 15 can be rewritten, or 15 is the same as 45 minus 30, and those are special angles that we know a lot about. We know their sines, cosines, and tangents, or can get them readily. So what we're going to do in this lesson is look at ways that we can find exact values for the trig ratios for angles that we wouldn't be able to do any other way. In the sum and difference identities for the cosine, you'll notice that in the difference identity, in the body of the identity, it's an addition, just pointing that out. In the sum identity for cosines, in the body where you actually do the work, it's a minus, and that's something that we'll want to be aware of. In order for us to use these identities, we have to know either what the two angles are and be able to know their cosines and sines, or it's possible that we could be given the cosine or sine of two angles and asked to work from that. Let's take a look at an example. We're asked first to find an exact value for the cosine of 165 degrees. I always believe that a sketch will help, and so 165 comes out this way. If this is the 165 degrees, we do trig with the reference angle. Folks, the reference angle is this one, and I would ask you to think about that. The reference angle would be 180 minus 165, since we're in the second quadrant there, and that is 15 degrees. Fancy that. We know that 15 degrees can be rewritten, folks, as 45 minus 30, and that gives us enough stuff to get going on this. This would mean, for us, we're going to call the 45 degree angle alpha, we're going to call the 30 degree angle beta, and we need to know the values of sine and cosine for 45 and 30. Those are on your trig reference sheet, or I hope, will have them memorized before too much longer. The sine at 45 degrees is square root of 2 over 2, and the cosine at 45 degrees is the same thing, square root of 2 over 2. The sine at 30 degrees, if you don't have that memorized, again, I hope you will soon, it's 1/2, and the cosine at, this is 30 degrees. The cosine at 30 is root 3 over 2. So these are all the inputs that we need in order for us to find this cosine that we've been asked to locate. So we can say that the cosine of 165, which is in the second quadrant, I know it's going to be negative, so I'm going to start my calculation out with a big minus sign, and I'll put things in parentheses after that. The identity says it's the cosine of the alpha angle times the cosine of the beta angle, and since we're doing a difference, it's a plus in here, then it's the sine of the alpha angle multiplied by the cosine of the beta angle. Now we have values for all of those that we can substitute in, so here we go. Cosine of 45 is root 2 over 2. Cosine of 30 is the square root of 3 over 2. Then it's a plus sign, and we're talking the sine of 45, which is root 2 over 2, times the sine of 30, which is 1/2. Now, that's just some ugly fractions, but they are just fractions. That would give us the negative of, and when you're multiplying fractions, it's top times top. Root 2 times root 3 is root 6. Bottom times bottom is 4. We have a plus sign in here. And then it's root 2 times 1, or root 2, over 2 times 2, 4. Now, ladies and gentlemen, if we leave this alone just as it is entirely appropriate. There are other ways that you could show this answer. If we're going to think about negating all of this, we could say it's the negative square root of 6 over 4 minus the square root of 2 over 4. Additionally, we could also say this, that it's the negative square root of 6 minus the square root of 2 all over 4. Any one of these three answers is correct. They all signify the same thing. And I'd like to have you demonstrate that for yourself. So I have my calculator up here. Excuse me while I get it up. My claim is that we've found the cosine of 165 in exact value. So I want to just test that here. I have my calculator set up in degree mode, and I'm going to ask it for the cosine of 165 degrees. Negative, which we know it should be, 0.9659 it says. My claim is that any one of these fractions ought to give us that same value, and I'm going to use the last one here. The negative square root of 6 minus the square root of 2 and then we need all of that divided, so I'm going to hit enter here, all of that divided by 4. And look at that, negative 0.9659. That identity gave us the exact value of a cosine of an angle that we could not have figured any other way, and that's kind of cool. Alright, let's move on and look at the sum and difference identities for the sine. Those patterns are printed in your notes, folks, because I do not want us to get the SIGNs wrong in these things. So we have the sine sum identity. This time instead of multiplying cosine times cosine, this is sine times cosine. Notice that the SIGN in the sum identity is a plus. The SIGN in the difference identity is in minus. So these are using the same factors but just set up a little bit differently. And the problem that we've given you here is a little bit different as well. It says find the sine of x minus y. We don't even know what those angles are. If both the angles, x and y, are in quadrant 1, with the sine on x being 4/9 and the sine on y being 1/4. Alright, we need to do some work. We need to know the cosines of these angles as well. We have their sines, so we should be able to use what we've done before to find their cosines. If the sine on angle x is 4/9, the sine, you'll remember, that's the y coordinate with the radius. So that means we're out here somewhere where the y portion is 4, the radius is 9, and we need an x to find the cosine. Pythagorean theorem is our friend here. And since we're looking for a leg, it's going to be hypotenuse squared minus leg squared. So let's see, that's going to be 81 minus 16. X is going to be, that's 65, the square root of 65. So the sine on x is 4/9. The cosine on x, root 65 over 9. Our other angle, y, we have its sine given as well, and the sine on that angle is 1/4. So that means that we're up 1 and a radius of 4. We can do that in our head. 4 squared 16 minus 1. This is the square root of 15. And so the cosine on angle y will be the square root of 15 over its radius 4. Now we have all the pieces that we need to find what we're asked to do, which is the sine of the difference of the angles. So I'm going to substitute into my identity sine of, and we're doing a difference, x minus y, and the difference identity calls for the sine of the first angle, so 4/9 times the cosine of the second angle, that's the square root of 15 over 4. we're doing a difference. So the sine, S-I-G-N, is a minus here, minus the cosine of the first angle. We found that to be the square root of 65 over 9, multiplied by the sine of the second angle, which is 1/4. Now we just have, again, some fraction arithmetic to do, but it's not too bad. It's all multiplying fractions, and there is a common denominator there. So 4 root 15 minus root 65, and all of that would be over 9 times 4, 36. And there you have it. We don't know what the two angles are, either one of them, but we do know what the sine of the difference of the angle measures is, and that's kind of weird when you think about it. Alright, here comes our last set of identities. These work for the tangent, and for the sum and difference of tangents you need to know the tangents of your two angles. We have an example similar to the last one. The cosecant of x is 5/3, and I would remind you that cosecant is the reciprocal of the sine, and that means that if we're talking x, y, and r, cosecant is r over y. Okay, so we know that. So our x angle here, the radius is 5, y is 3, so we're out here somewhere. That's a 3, that's a 5. We know that the x is going to be a 4, and the tangent of angle x, which is what we need, tangent of x, is going to be opposite over adjacent, or 3/4. The second angle, we have the cosine given, and cosine is x, so we're talking x and r here. So that angle is doing something like that, where that's 5, that's 13, and by the Pythagorean triples, I hope you'll remember that that is, y would be 12. The tangent, this is the y angle, the tangent of y is what we need, and its tangent would be 12 over 5, opposite over adjacent. Now we have all that we need, we just got to do a little arithmetic. So the tangent of x plus y is equal to, I'm looking at the identity up here, it takes the tangent of the first plus the tangent of the second. So we have 3/4 plus 12/5, and that all is over 1 minus the tangent of the first times the tangent of the second. So 3/4 times 12/5. Let's do some arithmetic. We get a common denominator for 4 and 5 up there, so I'm going to just work on the top of this right now. That would be 20. And let's see, 4 goes into 25 times, 5 times 3 is 15, so 3/4 becomes 15/20. 5 goes into 24 times, 4 times 12 is 48, so 12/5 became 48/20. On the bottom, we'll be better off if we write that 1 as 20th, because see how we're going to have a subtraction there. I'm going to say, well actually, yeah, I'm going to say I want that 1 to be 20/20, because that's exactly what we need. We're going to subtract from it 3 times 12, or 36/20. When you're multiplying, it's bottom times bottom. When you add or subtract, the denominator stays the same, but when you multiply, top times top, bottom times bottom. Alright, we just have to simplify some fractions here. 15 and 48 is 63, so we have 63/20 all over, and this would be negative 16/20. Well, I know and you know that those denominators both being 20, they're going to cancel out. We're going to end up with the tangent of x plus y equaling negative 63 over 16. Right? Tangent there, negative 63 over 16. You might be wondering why we ended up with a negative tangent when our angles were both in the first quadrant. Well, folks, you remember that what we are doing is finding the tangent of the sum of those angles. So when we added angle X to angle Y, we ended up out here in the second quadrant where the tangent is negative. Okay, gives us some food for thought. The patterns are easy to use. It's just we're going to have to watch the fraction arithmetic, and I hope that you will get out there and do that U-try as quickly as you can. Good night.